Hey everyone, and welcome. Today we are diving into a theory that's so far out there, a lot of scientists have called it crazy, and yet it's so fascinating that it just refuses to disappear. We're talking about the idea that consciousness itself, your thoughts, my thoughts, might not just be biology, but could be rooted in these super weird rules of quantum physics.
So let's just get right to it. The big question on the table. Is your brain actually tapping into quantum physics to think? I know, it sounds like something straight out of a sci-fi movie, but you'd be surprised. Some of the sharpest minds in physics are starting to think the answer could be a resounding yes.
And this whole rabbit hole really starts with what some called a crazy idea from a truly brilliant physicist, the Nobel Prize winner, Roger Penrose. He took a hard look at the mystery of consciousness and came back with a solution that was pulled directly from the quantum world. So that brings us to our first big idea today, Penrose's quantum consciousness theory. To really get it, we've got to start with his really bold and pretty unusual claim about what thinking even is.
Okay, so here's the gist of it. Penrose argued that our consciousness isn't like a computer program. It's not just a bunch of ones and zeros. He believed that real, genuine understanding needs something that an algorithm just can't do, something non-computable. And he found that something in the quantum universe, what's called the collapse of the wave function. Okay, think of it like this. You flip a coin. While it's spinning in the air, it's a blur of possibilities, right? It's kind of both heads and tails at once. The second it lands on the table and shows just one result, that's the collapse. Penrose thought something just like that was happening inside our brains, turning a wave of possibilities into a single conscious thought. That's a mind-bending theory, for sure. But, it immediately brings up a massive question. If these little quantum events are really happening, where on Earth, inside the warm, wet, messy hardware of our brain, could they possibly be taking place?
And this, right here, is where we meet the star of our show, the microtubule. Now, these are teeny tiny protein tubes that you find inside all of our cells. They're especially important in the brain, kind of like highways for transporting signals inside our neurons. And they're built from these little protein building blocks called tubulin.
I love how our source material puts it just brilliantly. It's tubes all the way down, people. It was these exact tiny structures that Penrose's partner in this, Stuart Hameroff, pointed to and said that's it. That's the perfect little stage for quantum mechanics to do its thing in the brain.
Now, I gotta be clear here. This whole idea was, and honestly it still is, incredibly controversial. Penrose and Hameroff got called crazy a lot. But here's the thing you'll hear from other scientists. The idea might be wild, but trust me, neither of these guys is stupid. They were taking a swing at one of the biggest mysteries in science with a really bold idea.
But that bold idea immediately smashed headfirst into a huge, very loud problem. It's a problem that physicists have been pointing out for decades, and it's known as the brain's noise problem.
And this slide just lays it out perfectly. Look, on one side, you have a quantum computer. To get those to work, you have to cool them down to near absolute zero. You have to keep them totally isolated from even the tiniest vibration. Why? Because quantum effects are just unbelievably fragile. And then you have the human brain. It's warm, it's wet, it's buzzing with electrical noise. It is literally the worst possible environment you could imagine for these delicate quantum states to survive.
So, the bottom line is this. For years, the biggest argument against this whole theory was that any quantum weirdness in the brain should just fall apart. It should get destroyed by all that heat and noise almost instantly, way before it could do anything useful, like help you decide what to have for breakfast. And for a long time, that was pretty much the nail in the coffin for this theory. But then, very recently, a brand new study, totally separate from Penrose and Hameroff, found something. A surprising quantum effect, right where they said it would be.
Yeah, a team of researchers who weren't even trying to prove the consciousness theory decided, hey, let's just test these microtubules in the lab and see what happens. And what they found, well, I don't think anybody was really expecting it. They saw something called super radiance. This is a real, honest-to-goodness quantum effect. It's where a bunch of molecules get linked up or entangled, and it lets them emit light in a way that's way bigger and more powerful than they ever could on their own. Okay, and this is where it gets really mind-blowing. They did these tests on microtubules, just sitting in a solution at room temperature, and they saw super radiance happening. But here's the kicker, the most important finding. The effect, and I'm quoting here,
doesn't care about the environmental noise. It was tough. It was robust. This finding flew directly in the face of that main objection we just talked about.
So wow, this is huge news, right? We've got hard proof that a strong quantum effect can happen inside microtubules. But what does that actually mean for the whole consciousness idea? Let's be super clear about this next part.
This is it, the million-dollar question. After all these decades of debate, does this new study finally prove Penrose's radical idea is right? And the answer, in one simple word, is no. And it's really, really important we understand why. Even the scientists who did the study are quick to point out that there's a big logical gap here. You see, finding a quantum effect happening inside one of the brain's components is one thing, but proving that this effect is the thing that creates your consciousness, that's a completely different story. It's a massive, massive leap in logic. So what's a more likely reason for this? Well, the study suggests that this super radiance trick makes microtubules amazing at absorbing dangerous ultraviolet light and then safely getting rid of that energy. So in other words, it's probably a defense mechanism for our cells. The scientists even think that maybe if this quantum process breaks down, it could be involved in some degenerative brain diseases.
So here's the real takeaway. This discovery is an absolutely incredible example of quantum biology at work. But it's almost certainly a case of biology using quantum tricks to protect itself, not to generate the incredibly complex experience of conscious thought. And that kind of leaves us with one last really fascinating thought to chew on. Okay, so maybe this study didn't prove quantum consciousness, but what it did prove is that powerful quantum effects can and do exist in the warm, messy, noisy environment of our own bodies. And that just blows the doors wide open. So if it's not being used for consciousness, you have to wonder, what other incredible quantum secrets has biology been hiding from us all this time?